integration 1 over 4 minus 3x dx. Okay, so when I have like this, I can say u equals 4 minus 3x. So then du will be minus 3 dx. Do you guys understand? Yeah. So then I need to know what is dx that I have here. So then you can see your dx is negative 1/3 du. So this will be 1/3 integration 1u du. See that? So I'm writing 4 minus 3x as u, and then dx is negative 1/3 du. Now I have here, my answer should be natural log of u absolute plus c. Then I take the substitution for u, natural log 4 minus 3x plus c. Now if you look at the domain of this function here, you will see that the domain is 4 minus 3x should not be 0. That's the domain. Also, if you look at here, since absolute value sign, only inside should not be 0. So the domain is preserved. Make sense? Okay. Let me take example number 4. Integral so that x to the 9 e to the x to the 10 dx. If I have integration e to the x dx, I know the integration, isn't it? What is the integration of e to the x? E to the x. But then you see that it's very complicated in here. E to the x to the 10. So in this case, this one will be taking as u. The reason is, when you take the derivative of x to the 10, that will give you x to the 9. So you can eliminate all the x in terms of u or whatever variable you choose. So I'm saying that my u is x to the 10. Now du will be 10x to the 9 dx. Now see that x to the 9 dx I see remaining here. So then in the substitution now, I can make x to the 9 dx is, this 10 will come in this side, 1/10, I cancel this here. So I write 1/10 integration e to the u du. See, my problem is reduced, and I mentioned that we already know integration of e to the x is e to the x. So then I can use that method now here, or formula, 1/10 e to the u plus c, and substitute back u as x to the 10 plus a constant. You are done. So that's simple. So example number 5 will be like integration natural log of x to the 5 divided by x dx. Okay, so the idea here is you choose one part as u, and then when you take the derivative, other part should come out. And that's why we can see that I have natural log of x to the 5. I can say u equals natural log of x. In this case, our domain is x greater than 0, as they have given us. So then derivative will be du is natural log derivative is 1 over x dx. So you can see here 1 over x. So this portion we have found already du. So then my problem is reduced to u to the 5 du. Now I can apply power rule. What is the antiderivative of u to the 5? You just need to add 1. So e to the 5 plus 1 is 6 divided by 6 plus a constant. And then you just say u is natural log of x to the 6 plus c. We are done. And in this case, this parenthesis is very important, because if you don't put parenthesis here, just a 6 here, it has a different meaning. So careful with the parenthesis. So this is another problem. I'll take another one, trig function type, number 6. This integration, we have said that sine 5t and then secant squared cosine 5t dt. Okay, looks very ugly, but it's very simple. The reason is, first I need to remember the derivative of tangent x. Who can tell me the derivative of tangent x, if you remember? So derivative of tangent x is secant squared x. So we can see here secant squared. If I consider this one as u or x, then there is a chance that I can integrate. And that is the motivation of taking your u equals cosine 5t. So you take u equals cosine 5t. And now you remember the chain rule of derivatives. So du will be, we know cosine derivative is negative sine 5t, and then derivative of 5t is 5 dt. Now you can see what I have remaining in here. I have sine 5t dt. This I need to replace. And you can see here sine 5t dt I have. So this 5, this negative, I need to move on other side by division. So 1/5 du equals sine 5t dt. And then you can see that the variables are completely transferred to u in very basic form. So I have negative 1/5 integral secant squared u du. Do you see the beauty of this substitution? That this has transferred my problem to the very basic form of integration. And we know that the integration of secant square is just tangent. So negative 1/5 tangent u plus integral constant. And substitute back what is u. Tangent cosine 5t plus c. And we are done. We have some other basic formulas now to remember, like when you have derivative of, say that sine inverse x, inverse functions, sometimes we also use arc sine. Arc sine or sine inverse, same meaning. This will be square root of 1 minus x squared. And if you find derivative of cosine inverse, then you just put a negative in front. So the basic rules are just like this. Derivative of tan inverse x, or you can say derivative of arc tangent x. So this derivative is 1/1 plus x squared. Okay, like that.